Hello people. So before anything else, let me show you the demo of this quantum tic tac toe, and let me just clarify that this thing is a little different than the normal tic tac toe that we play. So if you don't understand certain things, it's okay. Let's play. So my move will be 5 and okay 0. So let me take 2 1. Okay, I have a chance. I should take 8 now if I want to win. No, it did not work, it seems. So let me try 1. Again, that did not work. So let me take 9 this time. Okay, so quantum computer wins. Not quantum computer, but the computer wins using the quantum principles, maybe I should say. Actually, you can execute this on a quantum computer and play this actually with a quantum computer, but I don't think it will be correct to use a quantum computer to play tic-tac-toe. So this game is made using IBM Qiskit and Streamlit. And before anything else, let me tell you that this thing is completely based on something called quantum superposition. And before anything else, let me give you a brief understanding of what this quantum superposition is. Okay, so let us understand one of the most important principles in quantum computing, the quantum superposition. Just consider first the normal classical computers like the one that you are using to watch this video. These computers are based on a fundamental computational unit, which is called a classical bit, and this classical bit can take either of the values of 0 or 1. So it can be either in the 0 state or 1 state. Now, this 0 and 1 can be thought of like on and off state. Okay. And these computers, these classical computers, work on the normal electronics, the classical physics. Okay. But there are also other computers that work on quantum physics, and these computers are called quantum computers. Okay. And these quantum computers work on fundamental computational unit, which is called qubit. And this qubit is a quantum analog of the classical bit, right? And this qubit takes state like, for example, 0 cat, which is written like this, and this is called direct notation of writing the state, but actually this denotes just this vector. So this 0 cat is just a way of writing this vector, right? Now a qubit can also take other state, which is 1 cat, and which is a way of writing this vector, right? But here's the difference between qubit and the classical bit, that a qubit can take one more state, which is superposition state, which is neither 0 cat or 1 cat, but actually it is both all at the same time. And to be mathematically correct, it's actually written like this. Now, let us understand this concept with by using a coin analogy. Now, just take heads of a coin and just say that it represents 0 cat, okay, the 0 ket state of a qubit. Similarly, we have tails of the coin, which actually represents 1 ket. So given these conditions, when a coin is flipped, this flipping position of the coin represents superposition. So it's neither heads nor tails, but it is actually both the states all at the same time. So this is a simple way of explaining superposition. Now let us understand one more important concept, which is measurement. Measurement is just a way of getting output from your quantum computer. So like this, we have a state which is superposition state of our qubit, and if we want to extract output from our qubit, we need to measure it. And when we do this measurement operation, the qubit collapses into this 0 ket or this 1 ket. So the superposition state will either collapse into 0 ket or 1 ket, the only possible choices. And now with this basic understanding, we can proceed ahead to work quantum tic tac toe project. Thanks a lot. Hello everyone. So after that brief understanding of quantum superposition, let me give you a little overview of this game so that you understand what you are about to make. Okay, so this game is built using Qiskit and Streamlit. And with that said, let me show you the menu that you can see here. So this menu actually gives you three options, which is about, instructions, and play. Let us go to the about section. So in the about section, you can see this image first, which is just my channel logo. Then it gives you a little information about the creator, who is me, Jay Shah. And then this is created using Python, Qiskit, and Streamlit, as I just told you. Now, there's a little brief and mathematics about the quantum superposition. So a little mathematical notations and everything. So the important part here that I want you to focus is this psi, uh, the Greek letter psi, which here denotes psi ket, which is the quantum state here, and this is denoted like this. And remember this 0 ket and 1 ket from the previous section, and the superposition state. So this psi ket is just that superposition state, and these letters alpha and beta are the complex numbers. And if you just look here, these alpha square gives you the probability of psi collapsing to 0 ket. So remember that when a qubit is measured, it collapses from its quantum state to either 0 ket or 1 ket, right? So this alpha square gives you the probability that psi will collapse to 0 ket. And similarly, this beta squared gives you the probability that psi ket will collapse to 1 ket. Okay, and of course, alpha square plus beta square has to be 1. It's probabilities. Okay, so that's a simple overview. And now let's go to instructions. Okay, just a little understanding of the game here that I will explain you orally, right? So that this is what our board looks like, and this is the initial state of the board that you can see. Okay, so initially all the positions are in this superposition quantum state. Okay, and one by one player as well as the computer start making their choices. So the 0 cat actually denotes computer and 1 cat denotes the user. But the difference here is uh, from the plot twist in the Tic Tac Toe, that when you make your choice of the position where you want to play, so for example, I select this number, this piece here. If I select this as a user, there's not 100% probability that it will be actually 1 cat, because I am the user and 1 cat denotes my move, but there's not 100% probability that when I choose this piece, it will be actually marked as 1 cat. So it will actually go through the superposition state of qubit will be initialized, it will go through the quantum superposition state, it will be measured, and then it will either collapse into 0 cat or 1 cat. And based on that result, this the value of this piece will be changed from psi cat to that particular value that you get. Okay, so whatever and the same thing goes with the computer as well. When a computer selects a random uh, a piece in the board, there is not 100% probability that it will be marked as 0 cat. It can be 0 cat or it can be 1 cat. And that's something that makes this game fundamentally different from the normal tic-tac-toe that we play. Okay, and that's the overview. And I think you just understood what I just told you right now. And you can see already I have written here everything. Pause the video and read it, or never mind. I will be coding everything right in front of you. So even if you have not understood it, the while I will be writing the code, you will definitely understand it. And here's the play section. So I have already played the game in front of you, where the computer had win, but let me try it again. So you can see here I chose 4, which is actually this here, this piece here, and it was marked as 0 cat. And the computer's move was 5, which was here again randomly chosen and was marked as 0 cat. Now it's my turn to make the move, and let me just take it as 6. And you can see computer wins. So I lose it one more time. How bad is that? And if I try to make one more move here, say 1, you can see I can not just make any move here. No options to select. So no cheating at all. So that's a simple overview of the game. And after this, let us move, uh, just take the first step of working with the project, and that is installing the dependencies. Hello everyone. So after the overview of the game, let us start developing it. So how can you develop it? And as I told you that this game is built using IBM Qiskit and Streamlit, you need to install it first before you start using it, right? So for that, you can see we are on the Qiskit page, and they recommend using Anaconda to install Qiskit. And I will leave a video in the description that will help you to install Anaconda and VS Code. So VS Code is nothing but the editor that we will use to write the Python files. Okay. So using that, you can easily set up your Anaconda and VS Code. And once you are done with that, just uh, open up the Anaconda prompt And before opening this prompt, make sure that you have created a folder where you want to, you know, work with this project, where you want to store this project, right? And I have created a folder tutorial, and that's where I will be storing all the files for this tutorial. Okay, so when you open your Anaconda prompt, you will have something like this. So the base environment will be initially activated. So first I will do this conda deactivate, which will deactivate this environment, and then I will navigate to the folder, which is the tutorial folder, which is in the D drive. So again, tutorial. Okay, here I will use this command to create a new Conda virtual environment that I will name again as tutorial n. And this is one important step here, Python equal to 3.8, because Python with another version might cause certain problems with Qiskit. So to make sure that we don't run into any problems, just hit enter and it will start. And now you can see it's asking me for the permissions. So here it's asking me to give y or n, and here y denotes s, yes. Okay, so I'll just give y and enter. Now you can see it's working on creating the environment, and it will take a little time. So now you can see that the environment is created, and I need to activate this environment. So I will use conda activate tutorial n, which is the name of the environment. Okay, so let's do this, and you can see in the brackets we now have that name tutorial n. And after that we will just install the Qiskit and Streamlit. And okay, you can see if I scroll a little down here, you can see we have this command to install Qiskit for visualization purposes. Even the Qiskit pip install Qiskit will do, but I will go with this. So I will just select this, copy this, and note that if you are on Mac, you need to copy this command. So you will have Qiskit visualization in this single quotes. We get back to this, and now pip Qiskit install. So now you can see that we have Qiskit installed successfully. And now let me go to the Streamlit page, and you can see we have to just do this pip install Streamlit, and we are all good to go. So I'll do that, pip install Streamlit, and that's it. So you can see that Streamlit is also successfully installed in this tutorial environment, and that's it. You have successfully installed both the dependencies, and now we can freely work with our project. Okay, so let's start working with the project. So open the folder that you have created for this project. So open that folder using VS Code. So just right click on that folder, and then you will have one option that open with VS Code. So click on it, and once you do that, you will have this interface. Then what you can do is uh, right click and create new file. So we will create two files here, two Python files, app.py, right? And then another new file, game.py. So App.py will be used for the layout, the Streamlit layout, and some other parts. And game.py will be used for defining the functions for Tic Tac Toe, right? That we can directly import into the app.py. So we'll use that game.py as a module, and from that we will import certain functions into app.py. And another important thing is just have a look at the uh, environment here at the bottom. You can see it's tutorial N. Make sure that this is the environment where you have installed Qiskit and Streamlit. Okay, otherwise you will have some errors. And with that said, what you can do is open the Anaconda prompt, then again the same steps. Conda deactivate the base environment, then navigate to your folder, then activate your virtual environment. Tutorial, that's it. And now you can see we have tutorial and inside this bracket, so the environment is activated. Now one important command is streamlit run app.py, and then what you can do is just click just enter. So once you click the enter, a tab will be opened in your default browser. It's Chrome in my case, and whatever widgets you put using Streamlit into your app.py file, everything will be visible here. Okay, and the first step that you can do is just go here, go to settings, and convert this light to dark. So okay, this theme will convert it to dark. So we are programmers and we love dark theme. Okay. Okay, so let's get back to app.py, and the first thing is of course importing Streamlit as st. That's the convention. And if you face any errors here, then it simply means that there have been some problems with the installation. And if you successfully imported, then everything was just fine. Okay. Now this is the script that anyone is used to run. So we will indicate that using if name equal to main. We will just call the main function, and now for that we need to define one. Let's define a main function. So let's start working with it. So the first thing is, of course, you want to give menu in your game, right? So what are the main menu options that your user can have? And to do that, first we need to define a list. So play instructions and about. So these are the three options that I gave to the user. Definitely you can try more options or just vary these or modify these options. Okay, then what we will do is we'll take we'll define a sidebar select box. So a select box that allows the user to toggle between these options. Okay, and we will give it in the sidebar and select box, and then what you can do is give the title, which is just menu, and the list, which is menu. Okay, so the most amazing thing about Streamlit is that it treats all the widgets like simple variables, and by just using if else statements you can just create amazing things. as you will see in a while that by just using if else statements, I have created this project. I've tried to keep it as simple as possible because the intention was to help beginners. So I think it's really simple, and any beginner should be able to follow this. So let's again start working. So now note that whenever a user interacts with this select box, the user can select either play, instructions, or about. Okay. So we will handle it with these conditional. So if the user selects play, what we can do is st.write. Yeah. So streamlit dot write is just a Python print function. Okay. And we can just write this is play. Okay. Or we will use elif option equals instructions. Then what you can do is write st.write. These are instructions, or else in the default case st.write. Okay, sorry. This is about. So save this, and now let's get back to Chrome. So once you get back to the Chrome, just rerun it and you will see the interface here. So you can see a nice menu here. This is the title that we gave, and here as we gave three options. So here we have play, this is play, right? Or else we have instructions. These are instructions, and this is about, right? So I have given all the information regarding quantum superposition and everything in about, and for instructions I have given the instructions for the game. So I will just copy paste it here. So you can see I have pasted some content here, and in the for the about section. So the first is st.serve about. So this is just like HTML heading, it just the font size is bigger, and it just shows that it's a heading. So after subheader is done, you can see I have used one image here, and it's showing yellow because I have not imported image. So from import image, right? Now you can see. So this class is used for to open the image. So now you have the image stored in this image variable. Now you can use directly st.image and give your image to it, and then it will display your image. Okay. Then I define a simple docstring, and then I use just st.write to write it down. Then as I told you, I gave some basics of superposition and the mathematics about it. So I use st.markdown for it, and it's the simple markdown that we use. Same thing, and then I just wrote it. So I just save it, and if we go back here, you can see source file changed, rerun. Of course, no changes because changes are made in about. So you can see this is a subheading, my image. This is the image of my YouTube channel. So this is the image, and these are some equations and simple mathematics and some extra information about quantum superposition. So now let's get back to instructions. So now you can see I have changed the instructions part. Again, I use subheader st dot subheader to declare that this is the instruction column. Okay, and then you can just use psi, which is the Greek letter, and this notation psi ket is used to define to symbolize the quantum state. Okay, so you can just go to Google or any page that uses psi, just type in psi and copy it and then paste it in your VS Code so that you can use it as a string. Okay, and once you have defined this psi here, I have just used a NumPy array, which is a list of lists here, and this actually represents the board. So in the instruction column, I am trying to help the user to understand what is this game about. Okay, and you can see I have not imported NumPy here, and that's why it's showing that warning. So import NumPy 20, and I will also need pandas here, and you will see in a minute why. Okay, all the warnings are gone. So yeah, back here. So you can see I defined this NumPy array, which is a list of lists here, simple, and that actually defines our board, a 3 by 3 board, right? Now I use st.data frame here to that will display your board. Okay, so it will be a good tabulated representation, and this is just similar to pandas data frame representation. And if you don't know what does that mean, just think of it like Microsoft Excel sheet, right? So it's just like it will display in a very good tabulated form, and you will see in a minute what I mean. You have already seen the demo though, and again I have just written some more instructions here as a doc string, and then I use st.write to display these instructions. Then again I use pandas data frame here, which is pd.data frame. Again I input list of lists, and you can see st.data frame here also supports pandas data frame. So it supports pandas data frame as well as the direct NumPy array. Okay, again some more instructions, and I again use streamlit.write function to display these instructions as well. So let's go here. We are in the about section, and we play no instructions. Yeah, there we go. So you can see here, now I will use this moment to explain you the game if you have not understood it yet. So you can see this is the initial. This is the initial setting. This is the initial board that you see. All the places here, all the places are occupied by psi ket that actually represents a quantum state. So this is neither 0 ket nor 1 ket. It is both all at the same time. Okay, that quantum state that we saw previously. Now what happens is that as the game progresses, the user makes a move, and the user can only select one of these three boxes. Okay, so for suppose if I select box number 9, then ideally a 0 ket represents the computer and 1 ket represents the user. You can see it here, right? But the quantum effect here, so that now comes the quantum effect that actually makes this quantum tic-tac-toe different from the classical one. So what happens is, for suppose if I select this square, then there is not 100% probability that it will be actually marked as 1 ket, because I am the user, I am selecting the box, but still it may mark it as 0 cat or 1 cat, and it does that by running a quantum circuit. So what happens is it will run a quantum circuit, and based on the output of that quantum circuit, it will mark the value for this position. So as a user, you can only select a, a piece from the board, right? But the value is decided by the quantum circuit. And the same goes for the computer as well. Even the computer will can just randomly select a piece, and say for suppose this one, the middle one, and again the quantum circuit will be run, and the output of that quantum circuit will be used to give this piece its value. Okay, if the output of the quantum circuit is 0 cat, the value will be 0 cat, and if the value of the output of the quantum circuit is 1 cat, the value will be 1 cat. And that's the quantum effect, and that's the quantum tic-tac-toe, right? And yeah, that's the quantum tic-tac-toe. If you haven't yet understood, just try to go back and just try to understand this again. The instructions are in front of you. You can pause the video for a second, read it, and I am sure you will understand it. And the other thing to notice is that you have so quickly just coded two of your menu options, right? So we have three here: play, instructions, and about. So far, so simply, we have already completed working with instructions and about by just using, simple strings and variables, right? And simple numpy array. So that's the power of Streamlit. And since this project was, I wanted to keep it beginner friendly, that's why I thought of using Streamlit for this, because Streamlit is very, very simple to understand for anyone. With that said, now let's get to the play function, the play menu choice here, and the game.py file, and let's see how all of it fits together. Okay, so let's get to that. Okay, so now it's a great time to start working with game.py. So we will define a few functions here that we will use it there, so to keep it clean. So the first thing is, okay, yeah, now import Qiskit. And again, if there are any errors here, it just means that you have not installed Qiskit correctly. Once you are done with that, we will of course define a function here, right? So you can just define quantum superposition, and then we can just start working inside this function, right? So note that we will be using a quantum circuit using that will have just one qubit. And if you are not quite aware of what is this quantum circuit or a qubit, I already have a video explaining the basic quantum circuit, what is this thing is, and you can just you will get it in the description below or on the I button, as you might have seen by now. So let's see. So now what we can do, we can actually just import quantum circuit here. So from Qiskit, import quantum circuit. Yeah. So we'll define our quantum circuit. So we'll use circuit quantum circuit, and here we will give the number of qubits and the number of classical bits. So note that to extract and store the output of a qubit, we need a classical bit, and that's why what we will do here is that we'll just give 1 comma 1. So 1 qubit and 1 classical bit, and that's it. You have just defined the quantum circuit. Now we will use something called Hadamard gate. So in previous section, I just talked about quantum superposition, and this Hadamard gate actually puts a qubit into that superposition, right? So what we will do is circuit dot H. So H stands for Hadamard and qubit number 0. So the numbering starts from 0. So yeah, we have applied the Hadamard gate to it. Now what you can do is just directly measure. Okay, so circuit dot measure, I'll go this way, and it will be 0 comma 0, 0th qubit on 0th classical bit, and now we have just defined the measurement operation as well. So all the operations are defined now, but definitely you need a simulator now to simulate this circuit. Actually, you can also run it on the actual quantum computer, but I don't think it's fair enough to run this on a actual quantum computer. So once you have done this, Air actually gives you the simulator that you want. So now let's define the simulator. Simulator is equals to dot get backend, and we will define the simulator here. There are various types of simulator available. We will take on a simple one. Now once we have defined the simulator, we want to execute the quantum circuit using this simulator, and so for that what we will do is let's use simulator dot run, and we will pass our circuit. Okay, and then result. So what this thing will do is it will uh, run the circuit, and it will extract the result, and it might just happen that it will uh, execute this for a number of times. So you also want to get the counts. So dot get counts helps you to know for how many times the result was 0 cat and how many times it was 1 cat. Okay, how many times it was 0, how many times it was 1. So the dot get counts is just for that. So once we are done with that, I think we are done with it, and we can just return result here. So now we will definitely execute this once. So we will see a result and quantum superposition, and actually you should define the parameters taken and what is returning and everything here, what the function does. But I am not doing it here because I am just here to just show you the basic things and not to tell you much about Python. But whenever you are writing a Python function, make sure you do that. So I think I should just run this now, and no, I need to print it as well. Print, yes, and you will see how this thing works. take some time. And yeah, so what you can see here now is we have a Python dictionary. I hope you are able to see this. So you can see here we have got 0 521 times and 1 5 not 3 times. Okay, so let's do something more with this. So we can do is uh, keys. Okay, just we go first go with values. So list of result dot value. So we have dictionary, it's a key value pair, and then again we will get the keys of the dictionary, right? So we have both of it, and I will just print it again so you know what is what. So I will first print values and then I will print keys and I will run this thing again, and you will notice that here numbers might also change. Yeah, so you can see the first time we had run this, the 0 outcome was observed for 521 times, and the next time that dropped from 521 to 499, as you can see it here. That's the quantum effect. Okay, and now you can see from this dictionary that we have extracted the values, so this number of outcomes 499 and 525 here, and that we have converted into a list. Also we have got this thing, the keys, again we have extracted them, these, and we have converted it to a list. And now we should be like, why have we done that? And that's where I will give you your answers. So we wanted the value, right? So let's say random value. So we will replace, uh, we wanted to replace the check with that piece, square piece, right? So what we will do is, as you saw here, there are two numbers denoting the outcomes of the two possible the results. Okay, so what we will do is we will take the maximum number and return that. So here out of 499 and 525, 525 is bigger obviously, then we will return one cat. Okay, we will just return the value that we want to give will be one cat to that particular piece. So that's the logic that we are trying to get here. So for that, what we will do again, we will just use, initially I just use the string. It is just not one, it's one cat, remember. And then we need to convert this thing into string and plus another string, this. Now it's a simple logic here. So the keys of np dot argmax of the values, right? And I just remember that I haven't imported numpy as np. That's the standard convention. So what's happening here is I'm checking into the values that which is the highest value. Okay, and uh, that's where I'm getting these keys. Okay, because it's not necessary that 0 and 1 will be in this order all the time. Okay, it can be in this dictionary that it returns, it can be 1 and 0 or 0 and 1. So you never know, it's not like that the 0 will be the first key and the 1 will be the second key, or every time. It can change, so that's why we are just using the simple logic here, that we're just trying to get the position of that highest number, and for that one we will get, for the same index value, we will return from the keys list. So for example, here we had 525, the highest value, and so that we will be having this string one cat. Okay, so let's again run this thing, and this time I'll also parent a random value so you can understand better. Okay, let's run this one more time. Yeah, now just concentrate here. Oh my god, that's an equal case that we got here, and but it's selected 512 here because it's first. That's the logic here, because 512 wasn't counted first. It's selected for 1 here. I think I need to run this again. This is the quantum effect all of us enjoy. Uh, let's run this again. Yeah, this time we have got unequal numbers. And this time I'll be able to explain you. Yeah, again you can see we have a dictionary here, and you can see this time the key 1 is placed before the key 0, and that's why that logic above is really important. Now you can see again here the value for key 1 is higher, so we will return 1 cat, and you can see the value printed here, 1 cat, and that's the random value. Print random value, you can see here, and we have successfully used our logic, simple Python logic, and you can see we've got 1 here. So that's simple quantum computing using Qiskit, and let's just wrap this thing in a function. Okay, so we'll just define another function, and the function will be get a random value, and we will just put everything in this function. Just delete these print statements, no longer required. The print statements were just there to help you understand what's going on. Return random value, because it's a function, you need to return the value. And yeah, so the quantum part is over, and if you haven't yet understood, try to go again through it. If you're not understanding from this video, I have other videos on the channel to check them out. Go to internet, IBM Qiskit has its own documentation, you can go there, or just pause this video a little and just look at the screen and try to understand the code. But I think I just gave sufficient information that you require to understand it. And now let's put the last component of this game.py, which is a simple tic tac toe logic for the game that I have already explained in a video on this very channel. So I will just copy paste that logic here, and again I will explain you, but I will not write the code. And if you want to still understand the code, or you're just confused with anything, you can watch that other video where I have explained everything very nicely. Okay, so let's do this. See, so finally we come to the last component of this game.py file. You can see I've copy pasted a function here, and this is the second last part for the project. Okay, let's get to the point here, and you can see this is the validate function that validates who has won, and if the game is finished or not. If it is finished, who has won the game. So and yeah, just that's how you just define the parameters and everything. Just define that. It returns 0, the method returns 0 if any of the winning condition is satisfied by any of the player. So either the user or the computer, if anyone is 1, the function returns 0 or the function returns 1. So now we can come here. This logic is really simple, and I'm not imported Streamlit in this file, so I will do that here. Streamlit as SD. All the warnings are gone. Now let's get back here. You can do here. Just see here. You just define a boolean variable flag here, 2 strings. Then I just simply check for the conditions here. So the principal diagonal condition with respect to user, the main diagonal from top left to bottom right, that diagonal. If that condition is satisfied by the user, that is checked using this if condition here. And if it is the case, I just st.success is just it just prints the string, but it's in a nice green box, so it just just symbolizes success. So that functionality is provided by Streamlit here, st.success. And if that's the case, I keep this flag false, and similarly I just check for different conditions. So again, the principal condition with respect to user, then the second diagonal condition with respect to user again. So this one was, so first I check for a condition for user, then I check it for the computer. Again I just come to another condition for user. This time it is just that the second diagonal condition, from top right to bottom left, that diagonal. And if that's the case, I will just declare user has 1. I will check that same condition for computer. And now again, this simple logic here. If not flag, then return 0. So flag is just false. So if not flag means that if not false, if true, return 0. So it just means that one of the condition is satisfied and it will return 0 and the function will be executed successfully. But if flag, so you can see the below for loop the below for loops are executed if and only if any of the conditions above are not satisfied. So it means that the value for flag is still true. Okay, so if flag, and again I just look for all the conditions. So if any of the row is conquered by the user, then I just print user has 1. Here you can see, and the same condition is checked for the computer, and if that's the case, I just print computer wins. Then I come back here, I check it for the column wise. Okay, so if with respect to user, if any of the columns are conquered by the user, then I just print user has 1. The same condition is again checked for the computer. And the last condition here is if anything of above is not met, then it clearly is a draw. No one is 1. And if that's the case, we still return 0. And this is the condition for that, so that if psi is no longer present in the board, it means that all the square and pieces are occupied, but still none of the winning conditions above are satisfied, then it means it's a draw, right? And then if that's the case, we return 0, or else we return 1. And that's it. So we have completed working with game.py, and if you are still confused, you can watch my video. The link will be in the description, where I have simply that video was about coding the simple Tic Tac Toe game, but it's similar to this, and the only difference is about 0 cat and 1 cat are just replaced by 0 and 1. That's simple logic. Nothing. It's really simple, and I think you can still understand even this explanation. It's simple coding logic. Okay, so we are done with this. So we are done with game.py. And so what we will do is we will just import these modules. So what I'll do is from game import get random value and validate. So note that we have three functions here in game.py, but this quantum superposition function is just used by get random value. Okay, so that's why we just need to import two functions here. So we are done working with game.py, and now we will come to the last part of the project here, where we will code this play option here. So I think this is the most interesting part. And again, here I've just used simple if-else statements. So I think it will be really easy for you to understand. And here we will also come across some core concepts of Streamlit. So if you are someone who really wants to get into this Streamlit, explore it more. So we will come across those concepts that I will explain in the next part. So I hope you are excited, and let's do that. Okay, so we are back to app.py, and you can see I've written a few statements here, simple subheader and write statements. And now I am about to introduce a very important concept of Streamlit, a very core concept of Streamlit. So note that every time there's a user input in the Streamlit, the the app script runs from top to bottom every time. And this thing can be problematic in certain cases. For example, say you have created a web page that asks for username and the password to a user, and then there's a submit button. So the user types in the username and the password and then clicks on submit button. And since that's a submit button, it's a user input, that there can be situations where it will rerun again, and it will again ask for username and password. So again, there are multiple inputs, that's why. So this thing can be really problematic. And as a solution to that, uh, Streamlit has come up with this concept of session state. So, inside this session state, you can define your variables as session state variables. And then what happens is the value of your variables is preserved through reruns. Even if the user input is given, the app is still rerun, the script is rerun, but those special variables of session state, their values are preserved. So any difficult situation, problematic situation can be avoided because of this concept of session state. And in our example, say we are using a NumPy array as our board, right? So just think about it, that the user input is given, and every time if the script runs from top to bottom, and every time there's a rerun, the content of the board is lost every time it initializes from the initial state after every input. And that thing is really problematic, right? So that should not happen, and that's why we are using this session state concept here. And now I will tell you how this will work. So just we will define if board. So this will be the simple name of your variable that you are about to define in the session state. So if board not in st dot session state, then st dot session state dot board equals, what you can do here is just define it, and it's an numpy array. So what you can do here is, because I am lazy, I will just copy this from link option and I'll just paste it here. Yep. and you can define other session state variables as well. So the other variable that we will use will be the available moves. State dot available moves, and I will tell you in a minute uh, what's the use of this available moves. Okay. Okay. Now note that if board, this board is actually this session state dot board, and when the app is run for the very first time, it will see that this variable is not defined in this session state, and that when that's the case, it will define it this way: session state dot board in this initial conditions, and later on these values will be in this state. Okay, so when the next time it runs from top to bottom, this condition will be false if board not in session state. Okay, because these values will be present in the session state, and therefore this initialization will not occur, and the updated value will be preserved. So that's the simple logic here. Okay, so now let's get to the more important part here. Now, again, as you saw in the demo, I use a select box or drop down for the user input, and let's do that. So again, as you saw in for the menu, we defined a list here, as you can see here. Defined a list and then define the select box. Similarly, we need to do that, but note that here we have already defined this available moves, right? So the list is already defined. So what we can do is we can just directly go with the select box. And again, there is a change here. It's not a sidebar select box, it's the direct select box. So the previously we got that select box in the bar, in the sidebar, okay? But this time we'll get it in the main area of the app. Now we'll just define, make a move, the heading of the select box, and we will give this list. Okay, session state dot available moves. Yeah, and now as you might have just guessed, we will define one condition for each possible move. So here, we have these three conditions. Sorry, these 9 conditions here, 9 possible moves, because it's a 3 by 3 grid, so 9 possible options, and each piece in that grid is numbered from 1 to 9. So the user selects one of these options, and accordingly the further processing happens. So now let's see how that's done. Okay. Okay. So let's get here and check for all the possible conditions. So the first condition is the value for the move is 1. Okay. Then we'll check for another nested if using another nested if condition. We'll check for more condition that st dot port of 0 comma 0. So the value 1 actually represents 0 comma 0, the first top left square. Okay, and that is numbered as 0 comma 0, right? And so that value should be equal to psi, and I'll tell you why this is important. Because say your user has selected the option 1 once in the gameplay, and the user again chooses that one of one choice. Okay, and the value will again get changed, right? And that should not happen. So if the user selects the uh, any option once, then even if the user selects the same option again, nothing should happen. and that's why this condition is important. So recall that every uh, every piece in the board is initialized initially to the value psi, and if a particular piece is selected by the user, then that move that either the user or the computer, that piece value will not be psi anymore. It will be either 0 ket or 1 ket. And using that logic, we just define this condition here, so that if the user has once selected a particular piece, the user cannot select it again. So no cheating here. Okay. Now inside this condition, we will get to the actual thing. Now we have already we will now take the user. You just took the user move. Now it's time to update the value, right? So to update the value, we'll just do st dot, again we need to go to our board, again 0, 0, and now we use our function get random value. So this get random value is our function that we imported from our game module, and now we will see if the user has one, and for that we will use another variable, and we will use our another function that we used that we created in the game module. This time is validate, and we need to give it the board, which is st dot. Okay, sorry. Yeah, now it's fine. So so what we do here, we get that random value and update the board here using get random value, so either 0 ket or 1 ket, and then using this validate function of our game module, we see if the user has one. Okay, the after getting this new value, and after doing that, we have either got the user flag having the value 0 or 1, and 0 the value will be 0 if the user has 1. Okay, and note that 0 corresponds to false. Okay, so if not user flag, so if not user flag is like if not false, so if not false is if true. So basically if the value of the user flag is 0, it means that if the user has 1, then we will just write it, we'll just display the data frame, which is again nothing but a simple board. Then what we will do is we will reinitialize the states. Available moves. So recall that we had this available moves list in the session state, but if the user has 1, then the user should not be able to make any other move because the game is over, right? If the user has 1, and to do that, we just reinitialize the state of this available moves list. So this list is an empty list now, so the user will not have any options to select from. So now we are done with the user part, so let's get to the computer now. So after the user has made its move and it's validated, it's computer's turn to make its move, and for that we will use the random module of numpy, and so I'll tell you what this does. So the random.readnet will give you a random value from 1 to 9, one value randomly picked from 1 to 9, so that will be the range from 1 to 9 both included, and that will be the comp square. So the way user will select one of the values from 1 to 9 using that drop down, we will give a computer a chance to select either one value from 1 to 9, and after that we want to update the value for that particular piece that computer has selected, and for that we will require the row number and column number of that particular choice that the computer has made. Okay, because each of these numbers 1 to 9 actually represent a particular square piece in the board. So we need to calculate the row and column. So let's just calculate the column first. So comp square minus 1, put this in brackets, and this will be, sorry, mod 3. So this logic actually gives you the column number, and if you don't trust me, you can just pause this video for a second and just calculate it. Now let's get to the row value. So we need row value as well. So again, what I'll do is comp square minus 1, and here I will just do a simple division by 3. So this will give me the row value. Simple logic, and I don't want any float values here. So I'll just do this math dot floor, and yeah, if you have not imported this math module, just import it. And now we will just update the value in our board. So it will be row comma column, and again our helper function get random value, and that's it. We have updated our piece that was selected by the computer. And note that if the piece was already selected, then it won't be updated. And again, we need to make a condition for that. So let's do that and go ahead. Session state dot board equal to it will be psi. Oops, row column. Now what we'll do here is then okay, there's one thing. If I do it here, then it won't make sense. Just store it in another variable, say comp value, and then I'll just copy paste this here. Yeah, now this will make sense. Then it will be comp value. So what happened? Let me just tell you again what just happened right now. So I just randomly got this value. I just created this variable comp value, and I just got this output from get random value, and I stored it in here comp value. Now this comp value has either the value of either 0 cat or 1 cat strings, but here I check if this particular piece is equal to this psi. So if the again just recall, the psi was the initial condition for each piece, and so if the value is psi, it means that that particular square piece was unoccupied, and if it is unoccupied, then and only then we will update that particular value, right? That's simple logic. With that said, now we will again have to validate if the computer has won, because recall that we just got this value for the user move, and we again validated it. Now so the same goes for the computer as well. we need to validate it. So let me just define it as computer flag and validate, and of course I will give it state dot board. So it will again check all those possible conditions that whether any condition is met or not, and if it has, then it will give me the value as 0. So again, if not comp flag, so then return 0, right? So comp flag, the value for comp flag will be 0 if any of the condition was met. Then what happens is, if it will be if not false, and if not false is if true, then it will be return 0, and the main function will be executed by returning this value. But for suppose if the none of the condition was met, so the user value was also neither the user has won right now, nor the computer. So then this will continue, right? So what I'll just do is I'll just write the computers move. Okay, so this is nothing but the square piece value that was selected by the numpy random module, and this will be comp square. Okay, then I'll also print the value that was replaced, that the computer got using that get random value function. So computers value and V capital. I don't know, I do that, and now that will be comp value. Yep, and then I will just print the board because it's important. The user should see what's the condition of the board, and in here we will just use our board session state board variable, and that's done. Now one last thing here remains is that the else condition. This else condition is in accordance with the condition here for this particular if. So all this below code is executed when the user move selected was was selected for the first time, and the initial value on that particular piece was psi. But what if that is not the condition? Then what we'll do is we will just define one else here, and then what we'll do is st.data frame of st.data. We'll just print the board. We will not do anything. Literally, we will not do anything. We'll just print the board. That's it. And now the catch here is that you can just copy this block here and paste it 8 times, and the project is ready. The only changes will be here. This 0, 0 and this first statement here, if condition, and the 0, 0 value, this indexes for this board you need to change that for every possible value, right? For we have 9 possible values. I've shown you how it's done for the first one. What you can do is copy this, paste it 8 times, and then just change the values here. So for example, say for the condition equal to 5, so if if moves equal to 5, then it will be 1 comma 1 here, right? Row number 1, column number 1. So this is just that, and that's it. Your project is done. And how simple it was. It was really simple. And let me just copy paste it, and then we will just go back to the app, and I'll show you it for the last demo for this particular project. So one little detail, we were working with this main function, and the function returns 0 whenever any winning condition is met. So what we can do here is just create one variable, say condition, say condition, and we will check if condition, the value for condition is 0, and if that's the case, we will just declare game over, and that's it. This is a little detail that I want to give. So whenever anyone wins or it's a draw, it is displayed that yeah, the game is over. So let's work on the last part. So you can see I just copied this block, this one, from this main condition of moves option, and I just pasted it several times, and 8 times to be precise, and made certain minor changes. I told you the changes are only in these first 3 lines, which is changing this value for the move, and for these board, for the board, the index for the board to access that particular value. That's the only change. Other everything is same, and I tried to keep this as simple as possible, and I hope you found it possible. And let me know in the comments if you found it simple and something that was easy to follow. And another detail that I want to give is for here in this session state, we define the available moves, right? And we need to add one more here, which will be 0, and I will give you the reason for that. So the point is that the Streamlit takes the first argument as the default. So what happens is that if you don't give this 0, then the value that the default value will be 1. So what happens is that Streamlit will directly execute this condition here, that for the move 1. So that for the first choice, the value 1, everything will be directly executed even before the user selects it, and we don't want that to happen, and therefore we are adding this 0. We will not define any condition for this. If you want, you can just printing some random statements or something like that, even that's fine. I'm not doing it, and so we are just adding this 0 here in the list. That's the only change, nothing else. And now if I just get back to the project here, this app for the last time, or I need to save it, save, and then run. No, now you can see it's 0 here. And now we have these different values. Let's pick up 5. Computer shows 7 and the value was 0, so I'm just about to lose. Let me take 3. Thank God. And computer's move was 7 and the value was 1, but just notice that the value was the previous move's value was also 7, and now it was not updated, even though the random integer was again 7. The outcome was 7, but this time it was not updated because the value was already changed previously. So it's now again my turn. So let me take 6, 1. Again, the computer's move was 6, but my value was also 1, because if the user chooses something, then that value will be uh, as the streamlet runs from top to bottom. We have defined the user condition before the computer's condition, right? And therefore, when the user's move is selected, then the value changes from psi cat to either 0 cat or 1 cat. Okay, so the next condition for the user, for the computer, that if change the value if and only if the piece of the value is psi does not hold, and that's why no change is made later on. And with that said, let me try for 9. If everything goes well, no, it was 0. That's the fun of quantum tic tac toe. You can see the computer's move was again 6, then the value was 1 cat. Did not work again. We'll choose 1. The value again, the computer's move was 6, the value was again 0. And let me just take second. Yeah, user has won finally, after being defeated in those demos. And lastly, I've just won. And yeah, that's it from my side. I hope that you understood something from this project, you learned something, and if it helped you in any way, let me know in the comments. And until then, until next time, thanks a lot.